Dear students, today we are discussing about the median, and I think you have already done some problems. Okay, so this is a graphical interpretation of the median. So how can we draw the median curve? First of all, we have to draw less than, more than ogive curve. Then locate n by 2 on the y-axis. At n by 2, draw a perpendicular to the y-axis. Okay. Here we have identified n by 2. It is n, and locate the perpendicular and draw a perpendicular to the y-axis from here to here, and extend it made to here, and from that point of intersection of draw a perpendicular to the x-axis. This one is the perpendicular x-axis. So this point will be the median. Okay, so the point the perpendicular meets the x-axis will be treated as median. Okay, so this is the simultaneously we can plot the ogive curves. Both ogive curves we can plot both ogive curves, less than cumulative frequency curve and greater than cumulative frequency curve, and find the point in which the both curve are intersecting each other. Okay, so that will be taken as median. So this is the procedure of identification of median using graph. Okay, you know, we have as in the case of arithmetic mean, we have merits and demerits for median. What are the merits and demerits? Merits of the median are: it is more unduly affected by extreme items, it is simple to understand, it easy to calculate, another advantage is it is simple to understand, easy to calculate. It can be calculated for open end data. Okay, it can be determined graphically. It can be used for deal with qualitative data. Now, what are the demerits? It is not rigidly defined. When there are even number of individual observations, median is approximately taken as the mean of two middlemost observations. So if we have 10 observations or 12 observations, we have to take the mean of the two middlemost items. It is not based on the magnitude of all items, it is positional measure. Okay, we are just arranging the items and finding the middlemost item. So it is the value of the middlemost item. Okay, it cannot be algebraically manipulated. For example, the median of the combined set cannot be found from medians and size of the individual set of. Suppose there are two set of observations, then we will have two set of medians. So we cannot determine the median of the combined set using the individual medians. Okay, so that is disadvantage. But at the same time, in the case of mean, arithmetic mean, that is possible. If we have one set of observation, we have arithmetic mean x1 bar, and if we have another set of observation and having arithmetic mean x2 bar, then the combined arithmetic mean can be computed. So that is not possible in the case of median. It is difficult to calculate when there are large number of items which are to be arranged in order of magnitude. Okay, it does not have sampling stability. It varies more markedly than arithmetic from sample to sample, although all samples are from one and the sample population. Okay, it is its use is lesser than. You can see that we can see arithmetic mean in almost all studies or almost all research or almost all reports. So it is very rare to see the application of median in real data analysis. So very limited use is in the median. Okay, anyway, sometimes, but at the same time it is a good measure of central tendency. Sometimes we can use at the same time we should have keep in mind the disadvantages and limitations of the use of this type of the median. Okay, now we go to the another measure of central tendency, that is mode. What is mode? Mode is actually most frequently item. Okay, mode is the value of the variable which occur maximum number of times in a set of observations. Suppose there are some observations it is repeated frequently, so that can be considered as mode. So mode is a value of the variable which occur most frequently. Yeah, it is given there. And in the case of, so let us look at some examples. After that we will discuss this class frequency data. Okay. What is for example, consider the data 420, 395, 342, 444, 551, 395, 425, 417, 395, 401, 390. Okay, so what is mode? Which item is repeated frequently? Which item is repeated frequently? 395 repeated thrice. Okay, so we can take 395 as mode. Okay, so another set of observations given here. You know, it is the problem that is determined mode. Size of shoes is 3, 4, 5, 6, 7, 8, 9. So frequencies are 10, 25, 32, 38, 61, 47 and 34. Okay, so which item repeated more frequently? Since the highest frequency is 61, we can take 7 as the mode. Okay, we can consider 7 as the mode because 7 repeated 61 times. Okay. Another example is, so this is a class frequency example. So I think you got the idea of computing mode for the raw data. So now we consider the equation for computing mode for class frequency data. Okay, for a frequency distribution, mode is defined as the value of the variable having maximum frequency. For a continuous frequency distribution, it can be calculated using formula given below. That is Z equal to L plus delta 1 by delta 1 plus delta 2 into C, where L is the lower limit of model class and model class is the class having maximum frequency, and delta 1 is the difference between frequency of model class and that of the pre-model class. Okay, delta 2 is the difference between frequency of the model class and that of the post-model class. That means class after the model class. Pre-model class means class before the model class. Model class means the class having maximum frequency. C is the class interval. So for applying this formula, the class interval should be of equal size, should be in ascending order, should be in exclusive form. Okay, so that are basic requirement for computing, applying this formula for class frequency data. Now we look at the example. The classes are 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and the frequencies are given. look at these classes. These classes, the end point of the first class is not the starting point of the second class. So we have to arrange. So to ensure the intervals are exclusive, we have to modify like this. So the actual class is 0 to 9 is modified as minus 0.5 to 9.5. Then 10 to 19 is modified as 9.5 to 19.5. 20 to 29 is modified as 19.5 to 29.5. Likewise, we can modify all the classes. The corresponding frequencies are noted here. Okay. Now, what is the highest frequency? 33 is the highest frequency. Okay. 33 is the highest frequency. Okay. So, model class is corresponding actual class. Okay. So, 33 is the highest frequency, and the model class is 29.5 to 39.5, right? So that is the method of identification of model class. First of all, we have to search for the highest frequency and then locate the corresponding class. Then CMS set ആക്കണം പ്രിന്റ് എടുക്കും CMS പ്രിന്റ് എടുക്കും. So the model class is 29.5 to 39.5. Now let us find out the L equal to lower limit of the model class, that is 29.5. Okay. Now
ഇന്നലെ കോമഡി പാട്ട് പുസ്തകം എത്തി വന്നപ്പോഴേ 2 പുസ്തകങ്ങൾ
model class, and L is the lower limit of the model class, that is 29.5. Now what is delta 1? Delta 1 is the difference of frequencies in model class and class just before the model class. Okay. And delta 2 is equal to the difference between frequencies of model class and class just after the model class, that is 33 minus 22. So what are the difference? Delta 1 is equal to 16 and delta 2 equal to 11. Okay. Also you know that C is equal to 10, that is a class interval. Okay. C is equal to 11 is a class interval. So we can apply this formula, 29.5 plus delta 1 is 16 divided by delta 1 plus delta 2, that is 16 plus 11 into C, that is equal to 10. So after calculation we will get it is 35.42. Okay. So that is the so this, I think we got the idea of this calculation of mod. Okay, now we move to the relationship between mean, median and mode. For a symmetrical or moderately asymmetrical distribution, the empirical relation is mean minus mode equal to 3 into mean minus median. So what is the relationship? It can be expected in your examinations. So mean minus mode equal to 3 into mean minus median. So this relation can be used for calculating any one measure. Okay, if we have mean and mode, we can compute median. If we have mode and median, we can compute mean. If we have mean and median, we can compute mode. So if we have any two of the measure, we can compute the third one. Okay, the proof is not you are studying. You are not studying the proof. It is not given here. Okay. Now, so let us verify using some numerical example. It is given that mean is equal to 24.6 and median equal to 25.1. We have to find out the mode. So first of all, we write the equation, that is mean minus mode equal to 3 into mean minus median. That we can substitute that. That is 24.6 minus z equal to 3 into 24.6 minus 25.1. So that is z equal to, z means mode. Instead of mode, they have written z equal to 26.1. So that is the mode. Okay. So another problem is in a moderately asymmetrical distribution, mode equal to 48.4, median equal to 41.6. Find the mean. Again, we can apply same formula, mean minus mode equal to 3 into mean minus median. So instead of mean, they have written x bar. So x bar minus 48.64 equal to 3 into x bar minus 41.6. So by some algebraic operation and mathematical calculation, we can see that x bar is equal to 38.2. Okay. So we obtain the value of mean using value of median and mode. Okay. So similarly, we can compute mean, median, mode in different situations. So either we can directly compute or we can compute using these formulas. Okay. So you should study these techniques and you can write in your notebook and submit in the Moodle platform. Okay. If you have any problem in uploading the materials in Moodle platform, you may send to me through WhatsApp. Okay, no problem. But at the same time, you have to upload in the Moodle platform when it becomes active. Okay. So one more things we can discuss, that merits and demerits of mode. Okay, mode is unduly affected by extreme items. Okay, not affected by extreme items because we are considering only most frequent items. So there is no relevancy for extreme items. Another is, it is simple to understand and easy to calculate. It is most typical and representative value in the sense that it has the greatest frequency density. It can be calculated for open-end data. Okay, it can be determined graphically. Is x coordinate of the peak of the frequency curve. Okay, it can be found for quartiles also. So the qualities also, the quality which is observed more often than any other quality is model quality. And the disadvantage or demerits are, it is not rigidly defined. It is not based on all the items. It is positional value. It cannot be algebraically manipulated. The mode of as in the case of median, if we have two set of observation and we have two mode, we will have two modes, and we cannot combine that modes to get the mode of the combined data. Okay, so the mode of the combined set cannot be determined as in the case of arithmetic mean, but it is possible for arithmetic mean. Okay. Another, many times it is difficult to calculate. Sometimes grouping table and frequency analysis table are to be formed. It is less stable than arithmetic mean. Unlike other measures of central tendency, it may not exist for some data. Sometimes there may be two or more modes, and so it is said to be ill-defined. It has very limited use. Model weight, model size of shoe, model size of families. So there are several disadvantages or demerits. Okay, you can compare these merits and demerits of arithmetic mean, geometric mean, harmonic mean, median, mode, etc. Okay, so you can see that arithmetic mean is having more merits than, but at the same time we have to use mode and median. Okay, sometimes you are you are observing the flood level of a what is a dam. Okay, we are considering the maximum flood level. Okay, we are considering the maximum flood level. We are not considering the average flood level, because the maximum flood level is very important to, or the identification of maximum flood level is very important, because that affect our daily life or the people living in the what is that area of that dam. Okay, so in that case we have to use mode or mode value. Okay, so similarly there are situations we are particularly using mode and median. Okay, so but at the same time you can see most of the times you can see the arithmetic mean in most of the reports. So that is more flexible and it is based on all observations, and it is very easy to combine. So that are the reason for considering arithmetic mean. Okay, so you can study, you can read these merits and demerits simultaneously about mean, median, mode. Okay, now we will discuss the partition value in the next class. Okay.